types of linear equations by graphing. So we got 3 different solution possibilities. First one would be like this. So how would you describe the slopes of those 2 different lines? They are different. It's not rocket science here, people. Just algebra 2. Then we can also have identical lines. So let's say we had a line like that, and then we had a line like this. So 2 lines in the same, exact same, right? So they have the same what? Slope, and let's draw a little coordinate plane here. They have the same slope. What else is the same? Y-intercept. Excellent. Right, the y-intercept is where it crosses the y-axis. So the way I think about this, right here, it's independent because there's one solution. If you think about an independent person, they're off by themselves, independent. I can do it all alone, right? And then this one's dependent because every little dot along this line depends on the other dot because they're all on the same line, right? So that's why it's dependent when every single solution depends on the other. And both, basically, I think of consistent like it has a solution. Whether it's one solution or infinite. So it has a solution, then it is consistent. So you could draw yourself 2 parallel lines because that's about what I'm about to do. So you can draw a little coordinate plane. Oops, I made an arrow by accident. That's okay. Then we have parallel lines. Parallel lines, how could you describe their slope? Same. What's different? Y-intercept. So inconsistent is like no solution. Right? If you think about, I always relate it to people because it helps me remember. Inconsistent person, right? Doesn't make sense. It doesn't make sense because it has no solution. So if that works in your brain, you can think of it that way. If you can't think of it that way, come up with a different way to think about it. You guys can close your computers because you don't need them up right now. It's okay. I got power. Maybe. I do. You better. Is that a threat? Any of you guys participate in the Powder Puff game? I hear it got violent. Is that true? It was like full-on tackle at the end there. It's good. And you guys should have won, but didn't? It's always so annoying. It's always close, which is so weird. Oh, really? Who was it? Who? Okay. Brutal. That sucks. Got to be money in those moments, right? Okay. So, looking at these 2, I know I shouldn't have said that because then I lose the class for like 5 minutes. Focus, focus, focus. Come on. Come on. Shh, shh, shh. Stay with me. So, if we want to figure out if these equations on A and B, we'll do A first, obviously, are independent, dependent, consistent, or inconsistent, what form should we get those equations in? Y equals mx plus b, right? So I was like writing down the form that I'm going to be trying to work with, because then I can remember I want to get the y by itself. So if I rewrite this first equation, what should I do, Satya, to get the y by itself? Divide each and every part by 2. Excellent. When I do that, I'm going to get y equals 3x minus 7. Then I'm going to take my second equation, 3x minus y equals 7. What should I do first, Ellie? So is this 3x here positive or negative? So to get rid of it, we subtract it, right? So minus 3x. And what should I write 7 minus 3x on the right side of the equal? Anyone? Should I write 7 minus 3x or negative 3x plus 7?
Negative 3x plus 7.
Right, because we want to make it look like slope-intercept form. Can you tell they're going to be the same line or different line right now? Same, right? Because when I divide by negative 1, it's going to make the exact same equation. So if we look at these directions up here, determine the number of solutions. So how many solutions? It's the same line, infinite, right? So infinite solutions, we can just write infinite. I'll write infinite sol. Okay? Then we have to state consistent, inconsistent, dependent, or independent. Consistent, because it has a solution. Excellent. And independent or dependent?
Dependent.
Dependent, because it's infinite. Okay, next one. We have 3x minus 2y. Why don't you do this on your own? Talk amongst yourselves in your table group. And I will do it up here, freeze the screen, and you can see if you're right. Again, we're still reviewing Algebra 1, right? First couple chapters, that's what we do. So if you don't like that, move to advanced. I'm reordering the second equation. I recommend you do it as well. You could leave that second equation, the y-intercept should be 9/4. You can leave it like that as an improper fraction. What makes that fraction improper? What makes it improper? That's not why. It's true, but that's not why. It's a good guess. Numerator is greater than the denominator. That's what makes it improper. So, you know the problem when you guys take SAT, or if you're a sophomore, you take PSAT? The problem is it's really math language specific, and many times high school kids get really good at just kind of blowing off that math language. You're just like, I don't really get what consistent or inconsistent means. That's why I try to explain it to you, because it's so intense math language wise that you can easily screw that up. Question? It would be. Couldn't you see that plus? It was there the whole time. So weird. Thank you for catching my mistake. So what kind of lines are these? Does anybody remember? No. They have different, do they have different slopes or same slopes? Different, but they're specifically different, the slopes. Does any remember if you take the slope and you flip it and change the sign, what that's called? It's a negative reciprocal, and it makes the slopes perpendicular, right? So forming 490-degree angles. Doesn't particularly matter for this problem, I just want you to remember that. So if you take the slope and you flip it upside down and you switch the sign, that makes the lines perpendicular, okay? So are these lines going to cross? Yes. So are they one solution? One soul? At least it doesn't have multiple souls. Okay. Is it consistent or inconsistent? Consistent because it has a solution. And then dependent or independent? Independent. So it's a really good reference at the top of that page to help you remember the independent, dependent, consistent, inconsistent. So like let's say you have difficulty remembering stuff for a test. Does anybody use this test taking strategy? I used it my entire school career, high school, college, graduate school, and all the classes I've taken after. When I had a test, the thing that I had the most difficulty remembering, I would study it until the second I got the test. And then as soon as I got the test, I would stick it under whatever the little cheat sheet I had or whatever, stick it under my chair and then write it down right away. Is that cheating? No, right? I did it even when I took my comprehensive exams in graduate school. I had 4 25-letter string mnemonics, right? So a mnemonic, does anyone know what a mnemonic is? I learned one in 2nd grade, I still remember. This mnemonic is to remember the 5 Great Lakes. The mnemonic is HOMES, H-O-M-E-S. So the 5 Great Lakes are Huron, Ontario, Michigan, Erie, Superior. Because I grew up in Cleveland, we lived on Lake Erie. So I still remember that. So mnemonics are a powerful memory technique. If you ever have to remember things, so for me in my graduate school, we had to take comprehensive exams. Listen. We had to take comprehensive exams. I had to remember 3 years of material. Okay, I had to remember like articles, the author of the article, and the year it was published. And I had to be able to quote that when I wrote my comprehensive exams. We had 4 hours. We had to answer 3 of 4 questions, I think. And I wrote 22 pages in 4 hours, typed 22 pages. It was like a horrific experience. And then I passed. You know what you get when you pass? You get a 1-sentence letter from the university. My grad school is at CU Denver. You have satisfactorily passed your comprehensive exams. That's it. 1 letter, 1 sentence. I was like, yay. And I just spent like $50,000 to do that, right? And you get 1 sentence. They're like, thank you very much for your money, essentially. It was kind of depressing. But 22 pages in 4 hours. So with the mnemonic, right, I had 4 25-letter strings, and I'd make up little stories, like weird little stories, because then I could remember them. And then I could remember, and I wrote down vertically from those 25-letter strings all the stuff I had to remember, right? And it's a great way to do that. Okay, now we're going to graph. Again, we have to get it in slope-intercept form. So I'm going to rewrite the top graph over here so I can solve it for y. So again, we're plugging into y equals mx plus b. So we're going to subtract 5x, first step on the second equation, or on the first equation, I should say. Always write the x term first. So we get negative y equals negative 5x plus 3. Divide all three parts by -1. Some of you guys will get lazy and you'll write the big fraction bar with divide -1 and then you'll screw up one of your signs. And I'll take a healthy amount of points off and write ha, because I'm mean like that. Right? Don't be a knucklehead. So second equation, we're going to add x to both sides. When I do that, I get y equals x plus 5. So equation number 1 over here versus equation number 2 over here. Where do I start? Raise your hand if you know how to graph a line. You'd be surprised. Some people don't. So we're going to, equation number 1, I'm going to graph in blue. And I'm going to start at positive 5. And I'm going to go up 1, right 1. I can also go down 1, left 1. And then I'm going to draw my line. Put arrows on the end. Okay? Then I'm going to do my next one in pink. I'm going to start at -3, make it up. I'm going to go up 5, right 1. Are these lines going to cross? So the place that they cross is the solution to those two equations, which is kind of handy. That's why graphing accurately is important. You think I'll take points off if you don't put arrows on the end of your line?
Yes.
Hell yeah. Talked about it a lot, right? What is the solution? Anyone, raise your hand if you know the solution to this equation. Go for it. And then what's like the XY solution to the equation? It is consistent and independent. That's correct. 2, 7. Good. Okay. So when they say solve, right, 2's the x, 7's the y, what that means is if I plug 2 in right here, I get 5 times 2, which is 10. And if I plug 7 in right here, 10 minus 7 is 3. And that'll work for both of the equations as well. Okay? So that's what we're doing. We're going to solve the next one. Add 21x to both sides. So we get -6y equals 21x plus 24. Then we're going to solve the second. So what's the first step in solving that second equation, Jack? Huh?
Are there 2 Jacks?
Jack. Kennedy.
Oh, yeah.
What?
Did you repeat it?
Yes, I can. How do we solve this equation? What do I have to do? I'm trying to solve for y.
Divide by 6.
You see that little negative right there?
Or negative.
The second equation.
Second.
Trying to get y by itself. We do divide by -6 on the first one. You're correct.
Oh, I was looking at
It's all good.
7.
Minus 7x. I put him on the spot. Okay, we're dividing by -6, as Jack said. Funny, the two. Do you go by Jackson, Pendleton, or Jack? You go Jackson, you go Jack, right? That's how you know. Okay, so 2y equals -7x plus 16. Divide by 2. So first equation we get y equals, so bust out your graphing calculator, do 21 divided by -6, math enter, enter. You should get 7 over -2. So what are these lines? What kind of lines? Same slope, good. Same slope, different y-intercept, parallel lines. So if you look at the slope, it's the same, different y-intercepts, and you graph it and the lines aren't parallel, it's your built-in double check, right? So we start at -4, first line in blue, and then we go up 7, left 2. Up 7, left 2. Then we start at +8. This one in pink. So we can go down 7, right 2, right? We can go up 7, down 7, right 2, down 7, right 2. You can use math so you don't have to count it all. And the line should look parallel.
Okay, cool. Thank you.
So if we talk about the solution as inconsistent, consistent, dependent, independent, what are they? Just inconsistent, right? There's no independent or dependent. So we'd say no soul and inconsistent. Give me a fist of 5 in your level of understanding thus far. Okay. Grant, where you at, man? You didn't give me fist of 5, bro. I totally get it. I don't know what the hell you're talking about. Where you at? Now he's got to say, okay. Just asking. Right, it helps me to see where people are at, right? That's why I asked that. Okay, so we're going to write and solve a system of equations. Right? So Tanner's considering ordering prints of his photographs, the shipping fees and cost per print. So cost per print, right? That's going to be your X value. Shipping fees, cost per print for each site are shown. Write the equations to represent total cost Y. So it tells us that's nice. So total cost is Y. And then prints is X. So we're going to look at this little picture over here to determine, right? So it's 12 cents a print. So we can say Y equals 0.12 X plus 520. So 5.2. If you don't like the decimals, you can just multiply it all by 100 and you get 12x plus 520. Totally fine if you don't like the decimals, but it doesn't really matter. Then our second equation is y equals 0.25x plus 3.25. Okay. And then they've graphed it for us over here, right? So here's a 5.2 graph. Oops, I kind of whiffed on that. 5.2 graph right there. Here's the other graph right there. So what is this point of intersection?
15.
So let's see. How can we know that for sure?
We don't.
We think it's 15 prints. So here's what you can do. We're going to do this tomorrow anyway, so it's a nice little segue. So I'm going to multiply everything by 100, right? Because the decimals are going to annoy me eventually. So I'm going to say 12x plus 520 equals 25x plus 320. What did I just do? What's that called? Begins with an S, and then a U,
Solution.
and then a B. Substitution. Okay? So instead of this y right here, we wrote this multiplied by 100. So if I solve this, I always get rid of the smallest x first. Minus 12x, minus 12x. The what? Because when I multiply by 100, I have to multiply it 2 to the right, right? So 5.2 times 100, right? Doesn't that make sense? 5.2 times 100. Oh, I did something else wrong is what you're telling me?
For the second equation.
Oh, 325. You're right. My bad. Thank you for pointing that out. This should be 325 over here. The 5 just disappeared by accident. Oops. Of course, keeping me on my toes. That's good. So, when I do that, I get 520 equals 13x plus 325. What's my next step? Minus 325 from both sides. What's 520 minus 325? $195. Nice. So 195 divided by 13, you just did it, right? What is it, Cora? 15. Good. So we were right in our estimation. So how do I figure out the y value? So we can just plug it into, how about we plug it into this equation right there? So we know that y equals 12 times 15. We're going to have to divide it by 100 then. Plus 520 because I multiplied this equation by 100. So we'll have to divide our answer. So y equals 12 times 15 times plus 520. Which is 700, and if we divide that by 100, we get 7, okay? Okay, so 15 what? What are my units on the 15? John? What are my units on the 15? No, he's got to look real quick. Prince. They just threw you under the bus, right? Nice, well done. That's the kind of thing I used to do to my friends too. It's like, let's make him sound stupid. It's beautifully not nice. Well done. He's laughing, but looking at you with eyes of hatred at the same time. It's good. Yeah. Now he looks like a... Yikes. Okay, so we're good. I will come around and check homework in a second. Your homework is page 104. 2, 4, 6, 7, 8, 11, 14. Oh, actually, I take it back. We're going to do one more thing. It's going to be okay. You'll survive. So get your graphing calculator out. We're going to do example number 2. I'm going to show you how to do it in the graphing calculator. It's handy. You'll want to know how to do this, trust me. It's a good, quick way to solve a problem once you have SAT. Graphing calculator out, hit y equals. In y equals, you're going to put x plus 5 in y1. So we're going to hit y equals. I got some stuff in there. I'm going to put in x, which is right next to alpha. There's your x, right? It was x plus 5. I'm going to go down to y2, and I'm going to put in 5x minus 3. Now to get it to a regular window where it goes from negative 10 to positive 10 on y and x, if you hit zoom, top middle, and then we go to standard up there, which is number 6. So zoom 6 will get you to a regular window, and it'll graph your 2 lines. Okay? Super handy, right? So you put in x plus 5, 5x minus 3. You can just hit graph, right? Zoom 6 just gets you to that regular window. Now we want to find the intersection point. Okay, so you can double check your answer on a test. You can do this. Totally fine with it. We're going to go second trace. So trace is right here. Second trace. And we want to find where those lines intersect. So we're going to hit number 5. I'm just going to enter 3 times. Second trace, number 5, enter times 3. For you guys, you only have to hit it twice. So, oh, it doesn't work for me. That's not nice.
It's x2, y7.
I wonder why it doesn't work. That's weird. But that's how you do it, right? So you should get 2-7 when you do that. Okay? So how do you do it? What are the steps? Y equals. If you want to write steps down, not a bad idea, right? Let's write steps down. To find intersection in graphing calculator, I'm going to put GC for graphing calculator. We hit step 1, y equals. Right? I make it look like a button, so I remember to hit the y equals button. And then we're going to enter the equations. You got to solve them. I'm going to tell you which ones you can do in the graphing calculator in a second. Step 2, what do? We go second, trace, that's also a button, and then we hit number 5, which says intersection. Then last step, we hit enter times 3. Right? And then you will get the x and y values. So you can double check all of your problems on the test doing that, right? As long as you solve for y, that will always work, which is super handy. I'll tell you which ones you can use graphing calculator on in a second. Let me just stop the recording.